In this video note, we should be using the Scribble project to investigate the documentation and code completion features of the BlueJ environment. The Scribble project already contains a class called DrawDemo that includes some examples of how to use both the pen and canvas classes, and we encourage you to browse that class for some further background. In this video note, however, we're going to start with a copy of the Scribble project which we've called MyScribble. But we've removed the DrawDemo class and replaced it with the bare bones of a new class. We're going to add some code to this class to do some drawing and, in the process, illustrate some additional features of BlueJ. Let's start by adding a pen field to the class, because we'll need one to do some drawing. In the constructor, we obviously want to initialize that field with the new pen object, but what parameter does the constructor take? The obvious way is to look at the source code of the pen class. Opening the class and scrolling down, we can see that its constructor takes no parameters, so that's what we'll use. And let's compile as usual. Now we want a method to draw a line. We're only experimenting at this stage, so let's draw a line of a fixed length. What method from the pen class do we use to draw the line? Does it have a drawLine method, for instance? Once again, let's go back to the source code of pen to try to find out. As we scroll through, we notice that actually there's another constructor that we missed the first time we looked in this class. There's a move method which looks one possibility for drawing a line. Does it have a specific drawLine method? At this stage it's becoming a bit overwhelming to browse the whole class. There's a lot of code in there that we're really not interested in. We actually only want to know what methods are available, not how they're implemented. That's exactly the kind of view that the Java API documentation provides. Unfortunately, the pen class is not part of the Java API. However, we can actually see a similar view by changing how the class is displayed within the BlueJ editor. Either by selecting Tools, Toggle Documentation View, or by selecting Documentation from the menu over here, we get to see a more concise view of the class. This looks much more useful for finding out what methods the pen class provides. BlueJ is able to provide this view because Java doc notation has been used to comment all the methods in the class definition, just as it has for all the classes in the full API. Now we can concisely see the full list of methods of the pen class and observe that move is the one that we want for drawing a line. Notice that this view also makes it easier to see that there is more than one constructor. So now we can go back to our class and complete the method. That looks fine. Okay, now we're ready to draw something more complicated. Let's be ambitious and try for a 5-sided pentagon. This time we'll have the method take a parameter that specifies the length of the sides. The basic structure of the method will be a for loop. We know now how to draw each side. But how do we make the pen turn, ready to draw the next side? Once again, we could go back to the pen class and read the documentation. However, BlueJ offers an alternative. If we start to type the method call and then type Control space immediately after the dot, we're presented with a list of methods that can be called on that object. The ones in bold belong to the pen class, but here we won't go into what the others are. We can see that the method that we want is turn, and we can either select it by scrolling down, or we can start typing its name. As we do that, the list is shortened to offer just those that match what we've typed so far. Pressing enter at any point selects the one currently highlighted. This process is called code completion, and something similar is typically found in most programming IDEs. Now we just have to put in the number of degrees and add a semicolon. Let's imagine that we don't actually know the number of degrees, but that we do know that we want to turn 1/5 of a full circle, so that's 360 divided by 5. Let's try it out and see if it works. That looks fine. So we've seen how the documentation view and code completion can simplify our use of library classes. Now let's take another look at our draw pentagon method and make some observations about it. Firstly, that 360 divided by 5 is slightly cryptic. We used it because we couldn't remember how many degrees to turn to draw a pentagon. So let's make the meaning clearer by defining a local variable to store it, which will mean that the value will have a name. We compile as usual to check that we haven't broken anything in the process. Now we notice that the value 5 appears in two places, but both mean the number of sides because this is a pentagon. So let's define a variable for that too. Again, let's not get overconfident, but compile and test. Now, if we go back to the method, we might observe something quite interesting. The only part of the code that's making this method draw a pentagon rather than some other shape is the value of the sides variable. If we were to change the value from 5 to 4, say, would it draw a square? Let's try it out. Notice that the method is still called drawPentagon though. Indeed, it does draw a square. What about changing it to 3? Would that give us a triangle? Indeed, it does. So what we have is a method that can draw different regular polygons depending on the value of one of its local variables. The problem is that every time we want a different shape, we have to edit the method and recompile. That wouldn't be much good if we wanted to draw different regular polygon shapes in the same program. It would be much more useful if the same method could do that for us. So we shall end this note with a teaser rather than a solution. Can you think of how removal of the sides local variable and a couple of simple changes to the method's header would turn it into a method that could draw different regular polygons? As a clue, one of those changes to the header would be to rename it. The exercises in the book should help you further with this.